All right, this video is for Claire and Jalen, I think, unless anybody else. This is the last section of the chapter 8-7 Law of Cosines. I am going to be gone on Monday, and I'm going to give you guys a chapter review on Monday to work through, and then Tuesday we'll finish up review. Probably take a test over chapter 8 like on Wednesday of next week, depending on, track meets and whatever else. So tentatively Wednesday, maybe Thursday. We'll see how that works, okay? 8-7 is the law of cosines. We just got done with the law of sines. Now, at the top of the paper, I drew two different triangles because on the test, you're going to have these examples, and I will not tell you which one to use, but it's very easy to figure out which one. So I'm going to do examples, and I put an example of like when you use the law of sines and when you use the law of cosines. So we're going to talk through that. So kind of rough sketch those triangles at the top of your paper, and we will discuss when to use which one. Okay? I'll give you a second to do that real quick. And it doesn't have to be perfect. It does. Do a little rough sketch.
Mine look really bad.
I don't think I grabbed my calculator.
Yeah, I'm not getting mine out today. Somebody can do my homework for me.
Or you could just do your homework yourself.
Because I can't do it without Jalen.
So how have you been doing this week's homework?
I've been cheating. No, actually, I've been trying, but I'm pretty sure I'm doing really bad.
I strongly doubt that's a 105-degree angle.
I don't really
Yeah.
understand about that.
I don't know. Anyway. Okay, you got them all ready to go?
Yes.
Okay, the law of sines. I'm going to write down the formula for law of sines. It was like sine of A over A equals sine B over B, etc., right? We could do sine C over C, but you usually only do two at a time. So it doesn't necessarily have to be angle A and angle B. It could be angle C also. But you're setting two of them equal to each other. Sine of some angle over the opposite side, sine of some angle over the opposite side, okay? This law of sines you use when you have one group that you know everything about, okay? Like looking at this triangle, I have an angle and I know the value of the side that's opposite it, okay? Which group do I have there? 65 and 8, okay? Then I can put like the 65 here and the 8 here, and then I have one grouping, okay? Look over here at this right side one. Do I have a grouping there? No, like I have this. This would be a grouping if I knew what X was, but that's what I'm solving for, so that's the problem, okay? All right, you use the law of sines when you are doing two sides and two angles, okay? Two sides and two angles. Now, here, I had two angles. They were 65 and 50. And the two sides were X and 8. Now I realize that I'm solving for X, but that still involves two sides and two angles. One of those four things I'm going to be solving for, right? Does that make sense? Two sides, two angles, that's when you use the law of sines because the formula uses two sides and two angles. Does that make sense? Okay, so you just look at what you're given. Over here, the law of cosines, I have one angle right here and this side, this side, this side. Now I realize the X I'm solving for a side, but we're still involving three sides and one angle. Does that make sense? And when you have that going on, that's when you have to use the law of cosines. Make sense? Yeah? So three sides, one angle versus two sides, two angles. Okay? It just depends on the information that you are given. Okay, here's what the law of cosines looks like. Ready? Whew. Okay, C squared equals A squared plus B squared. Hey, that looks familiar. That's the Pythagorean theorem, except that's not all of it. Then we do minus 2AB, and we have cosine of capital C. The only capital, that doesn't look like a C. The only capital letter or the only angle that you have is inside of this cosine. This is an angle. Okay? That's a lot of stuff. Okay? All right, now, I'll let you write that down, and then we'll go to the formulas, because actually in the box where they give you these formulas, they give you three different ones, which is somewhat confusing, but I'm going to unconfuse you now. Ready? In the box, they have three different formulas. Holy cow. Okay? And it just depends on whether you're given angle A, angle B, and angle C, but it doesn't really matter. All these formulas mean exactly the same thing. Okay, we're going to take a look at this. So if you're given angle A, this side has to be side A. And then you have side B, side C, side B, side C, right? Whatever angle you're taking cosine of, the side that's opposite it has to be on the other side of the equal sign, okay? Like here when I was doing B, B was the angle. Guess where lowercase b is? On the opposite side of the equal sign. And then I have side A, side C, side A, side C, right? Okay? If I'm solving for C, capital C, or I'm given capital C, lowercase c is on the opposite side of the equal sign. And then I have the other two sides, A and B, right? So all of these formulas mean exactly the same thing. It's just you can use it for whichever angle you're given. Angle A, angle B, angle C. It doesn't matter what the name of it is, just as long as these two are opposites from each other, right? Like A squared and capital A are across from each other. B squared and capital B are across from each other. C squared and capital C are across from each other. That's all that matters, okay? So let's go down to this first example. Oh, man, I didn't erase everything. And it asks for us to solve the triangle. What does that mean? Find everything. Find everything. So we have angle A, we have angle B, we have angle C. We have lowercase a, lowercase b, lowercase c. And I first just look at the triangle and take inventory of the things that I have, and then like figure out a game plan of like what we need to find yet. Okay. All right, though that's all 6 things. They give me 3 of those. They will always give you three of the things, right? So I see 36 degrees over here. Where does that go? That's capital B, okay? All right, now, and then I see a 5. What's the 5 going to be? Little c, because it's opposite angle C, right? So little c is 5. What's 7? Little a, because it's opposite capital A. So we have 7, and that's all of the information that I know for sure 100%. Now, it's very easy to see at this point, if this was a test question and I didn't know whether I was using the law of sines or law of cosines, look at this group that I have right here. Do I have one variable that I know everything about? Like, do I have an A and a B and a B and a C and a C? Do I have any of those? I have like mix and matches. Like I have A here, B here, C here. I have no groups that are all together, right? I don't know anything about all that stuff, right? So this is only use the law of cosines, okay? And we're going to set it up because angle B is the angle that we have. So we're going to use like this middle one, this middle formula right here. I'm going to rewrite him over here. So we're going to use B squared equals A squared plus C squared, okay? Minus 2, and then I do A and C again, cosine of capital B, okay? Just as long as the B's are opposite from each other. That's what we care about, okay? All right, and we're going to solve for B squared. That's what we're first going to find because that's the only side that I don't know. So I'm going to leave that B squared as a variable, and I'm just going to start plopping stuff in, okay? So what was A? Was A 7? So this is 7 squared plus 5 squared minus 2 times 7 times 5 times cosine of 36. Okay. All right. And you can type that all into your calculator all at one shot. It might be helpful to do some of the calculations in your head, but I'm going to show you some things that are wrong that people do a lot. Okay. I'm going to show you ways to do this wrong so that you avoid that. All right. Let me just rewrite this. B squared equals 7 squared is 49. I can do that in my head. Plus 5 squared is 25. Okay, now I'm going to do this chunk in my head, but I'm not going to take 2 times 7 first. I'm going to take 7 times 5 first. That is 35. Do you know what 35 times 2 is? 70. That's easier to multiply that in that order. 36. Okay, here's the deal. As soon as you get to this point, do you guys remember Grant Streff it would have been? Do you guys remember who Grant Streff is? Graduated like 4 years ago, maybe. Mr. Streff's youngest son. Okay, Brett was the older one. Grant was the other one. Okay, scarred me for life because we would do these problems and I would tell him, Grant, you can't do that. When you type it into your calculator, you can't type it in that way. You can't do it. He's like, oh, okay, I got it. You get the right answer and then you go on to the next problem and you know what he'd do? The same stupid thing again. You type it in wrong. Okay, so I'm like, don't do it. Don't do it. Scarred me for life. I know exactly like what he was doing. So here's the deal. Here's what you cannot do, all right? If you add 49 and 25 together, you get 74. and then he would subtract 70 and he would get 4 cosine of 36. Don't write that down because it's wrong. What is wrong with that?
Negative 70 times cosine.
The 70 is attached to the cosine of 36. So that's great. You can put these two front pieces together, right? The 25 and the 49. You can put that together, but you cannot subtract 70 from it because it's attached to the 36, right? Or cosine of 36. So if you want to, in your calculator, type all of this in as one chunk, you sure can. 49 plus 25 minus 70 cosine of 36. You type that in, you'll be fine, right? But don't try to combine these three without keeping that 70 attached to the cosine 36, right? Let's try that. You people have your calculators?
Yeah.
You want to try this? Try figuring out what this chunk is, right? What's 49 plus 25 minus 70 cosine of 36? Tell me what you get. Like 17 point something. 0.36? Cool. If you type that in correctly, you should get 17.36, yeah? That's what b squared is. How do I get just b? Take the square root, and that's going to be like 4 point something. I think it rounds to like 4.2. Is that correct? 4.2. We will go on sides. We'll go one decimal place. So 4.2 is what b is. There we go. 4.2. Okay, happy with that? Do we see how that works?
Yeah.
Okay. All right, now. This is the wonderful part. Take a look at what we have now. What? We have all of our sides, right? Do we have one grouping of something that we know? Do we have a pair of information? Yes, we do. Now, typically, when we're doing this, we want to avoid using 4.2 because it's rounded, right? But when you involve the law of cosines, at a certain point, you can't do anything else without actually using it. So we will, when we're doing these problems, have to use one of the numbers that we have generated ourselves that we have rounded, right? So we'll have to use the 4.2. But from here, we can use the law of sine. So we'll do sine of 36 over 4.2. Would you like to solve for A or C? A. Okay, so we're going to do sine of A over what? 7. Okay, and we're going to cross multiply. So sine of 36 times 7 is 7 sine 36 equals, and I'm going to do 4.2 times sine of A. Okay, what are we solving for? A. So I'm trying to get this A by itself. So what are you going to move? I'm going to divide by 4.2. Okay, divide by 4.2. So somebody calculate this for me and get that decimal. It's like 0.98 or something like that. 0.98, okay. 98, something like that, okay. That's what sine of A is. How do I get just A?
Reverse.
Yeah, you do like that inverse sign or a sine -1. Now, hold on. For those of you who calculated this out, don't just type in sine of 0.98. Do you know how to use the answer button? So you'll need to type in like sine of the answer. It's like A and S, whatever. Okay, because then by doing that, that will use the unrounded version. So it'll use like 0.97, blah, 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 all the way out, right? Or whatever it was, right? So this will be the most accurate answer. What do you get? 78.42. 78.42. Okay, angles, we're going to round to the nearest degree. Okay, so we're going to go 78 on A. 78 degrees. So sides will round to the nearest tenth, or the nearest one decimal place. Angles will round to the nearest degree. Okay? Now, how do I solve angle C? Right, so I could do the law of sines again, but why would I do that when I can just add and subtract from 180, right? And I don't know what that is. What? 66 degrees. Perfect. Okay? All right. When you're doing these problems, you should only have to do the law of cosines, this ugly procedure, once to get one piece of information, and then from there you can do the law of sines again. Okay, we're going to do this next problem, and it's going to end up with with another interesting weird step that's different than the first one. Okay, we're going to skip example 3, but this one does end up with one little interesting step that we didn't have in the first example. So solve the triangle angle A, angle B, angle C, and we're going to end up with one weird thing happening. We don't have any angles. That's the problem. Yeah. Okay, so which one is little A? 16. Which one's little b? 9. Which one's little c? 10, right? Because they're opposite those angles, right? So we have all of those. Do I have a group? Do I have a pair? No, so I can't use the law of sines yet, right? Until we do the law of cosines. Which angle would you like to solve for first?
Sure.
Angle A, okay, sure, we'll solve for angle A. So when we do the law of cosines, that means we're doing the one that has cosine of A. So A squared has to be here. Then we'll have B squared plus C squared minus 2BC cosine of capital A. This is the formula from up above that we're using if we're solving for angle A. This is what we're doing, okay? And the problem with this one is we're solving for the angle, not the side like we were up above here. Here we were solving for side B. Here we're solving for the angle, okay? So there's just one little difference. And this one's just a little bit more of a pain in the butt.
Great.
But it's not too bad. Okay, let's start plopping stuff in. So we have 16 squared equals, I'm going to zoom in, 9 squared plus 10 squared minus 2 times 9 times 10 times cosine of A. By the way, these formulas I will not expect you to memorize on the test, so I will give you a note card. You can probably memorize the law of sines, like that one's not too bad, right? But I won't make you memorize this one. We'll just put both of them on a note card just so that you have them. Okay. All right, now here's the deal. This is where Grant would do it the most, right? Like he would try to combine stuff, so let's not be Grant, all right? 16 squared is 256. I'm going to do some of this stuff in my head. 9 squared is 81. 10 squared is 100 minus 2 times 9 times 10. Anybody know what that is? 180, okay? And cosine of A. Now, keep in mind, you can put these two together, but you can't put these three together because cosine of A is attached to that second one, okay? So, what shall we do? We're solving for A, right? A is all the way over here, which means that if here's my equal sign, everything else that's not A needs to be moved to the other side, right? Like that's what we have to do, okay? So we have to decide what we're going to move first. Can we add 81 and 100? Yes, let's add them together. This is 181. Okay, now what? Now subtract it over. Subtract the 181. This is exactly the order that you need to do. Subtract the 181. So 256 minus 181 is like 75, I think. Equals, what's it equal to? Negative, don't forget that there's a negative on there. Negative 180 cosine of A. Okay, now what? We're going to divide by negative 180, right? Because it's being multiplied to the cosine. So divide by negative 180. Okay. And we have cosine of A is equal to whatever that number is. It's negative. Negative 0.3 something. 3, 4? 0. I don't know. What's 75 divided by 180?
Negative 0.416.
0.416. Okay. There's that. Now how do I get just A? How do I get rid of the cosine? Inverse cosine. Inverse cosine. So it's the same procedure, but when you're solving for an angle, you will eventually have to use the inverse something. Inverse cosine, right? So do inverse cosine. Don't forget to put your negative in there. Negative. I guess use the answer button, right? Use the answer button so we don't have the rounded version. A is going to be what?
114.6.
114.6 degrees. Yes, you should. Use my head to search for it a little bit. Yes, so you'll have to do shift. Yes, exactly. There you go. Okay.
Will we round this to
There you go. 114.6. So, yep, we will round this to the nearest degree. So 115 degrees. Yeah? 115 degrees. Okay. All right. There we go. We have that one. Now what shall we do? Now we have a grouping, right? So we can use the law of sines. Remember I told you you should only ever have to do this nasty procedure once. Then you can use the law of sines after that, right? Okay. So law of sines, sine of 115 over 16 equals sine of, you want to do B or C? B over 9. Okay. All right. Cross multiply. So I've got 9 sine of 115 equals 16 sine of B. Then what? Divide by 16. Yep. Divide 16. Divide 16. Okay. So sine of B is equal to whatever that decimal number is. 0 point something. 0.51. Okay. And then roughly. And then inverse sine of that answer or whatever that is. Right? 30.6. Okay. And that's what B is. That's degrees. So we'll round to the nearest 1. And that's like 31 degrees. Okay. Then find angle C. Add them together. Subtract from 180. 34. That's what we got this morning. 34 degrees. Very nice. Okay. All right, you should only ever have to do the law of cosines once, then you should be able to do the law of sines to solve the second thing, whatever you're solving for. Okay, and then you're done. Okay, happy with that? Not too bad. It can sometimes be nasty. Just be careful and write out all your steps for when you're solving the law of cosines, because it's kind of nasty sometimes. All right, homework problems. You have 5, and that's all. Yeah, 5 problems, that's all. Okay, so on this page, I kind of tried to spread them out just so that like your work can run into stuff. So you don't have to do 2 and you don't have to do 4. So just 1, 3, 4, and 6 on this page, and that's all. You don't have to do the bottom ones, right? So I guess don't cross them off because then your work can go down into the bottom, I guess, if you want. So just 1, 3, 4, and 6, and on the back side do 2, and that's all. Okay. 1, 3, 4, 6, and 2. Okay? That's it. Happy Friday. All right. These are kind of a pain in the butt. So I'm gonna tell you, like, they do take a hot second of time. But you know, whatever. Okay? Good? All right. There you go. Bye, people in the video.